Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the division properties of exponents. Before we do, let's look at a couple of definitions of these properties. So let's start with the quotient of powers. If you have a base a raised to the n power and you want to divide it by the base a raised to the n power, you simply subtract the two exponents. So a to the m divided by a to the n equals a to the m minus n. Now in words, to divide two powers with the same base, that's very important, the base must be the same, simply subtract the exponents. So for example, if you had x to the 6th power divided by x to the 2 power, that would be x to the 6 minus 2 power, which is x to the 4. Now, let me illustrate why this property works. Let me write out x to the 6 in expanded form. X times x times x times x times x times x. So 1, 2, 3, 4, 5, 6 x's divided by x squared, which would be x times x. So this is literally what we're dividing here. Now, x, this first x divided by the bottom x, that would divide to 1. Anything divided by itself is 1. This would divide to 1. And what we're left is 4 x's. So we would write that as x to the 4 power. So that's why the subtraction property works. All right. Now, there's another property you'll be using today called the zero exponent property. And it says anything to the 0 power is equal to 1. So in words, any non-zero number raised to the 0 power is equal to 1. So say you had 4 to the 0 power. That would be equal to 1. Let's say you had x squared, y cubed, and all of that was raised to the 0 power. That would also be equal to 1. Now, let me try to explain why this works to you. Let's say you had 4 to the 2 power. That would give us a value of 16. What if you had 4 to the 1 power? That would be 4. So notice the pattern here. To get from 16 to 4, I would simply divide by 4. So if I had 4 to the 0, that means I would divide by 4 again. And 4 divided by 4 is 1. So 4 to the 0 power is equal to 1. Now you may think, does that only work for 4s? Well, let's talk about 5s. 5 squared is 25. 5 to the 1 is 5. So we're dividing this time by 5s. So 5 to the 0, divide by 5 again. 5 divided by 5 gives me 1. So anything to the 0 power will always be 1. Now, let's put these two properties in practice here. So in example 1, it says use the properties of exponents to simplify each of the following. So in problem A, we have 16 m to the 9 power, n to the 14 power, and they want us to divide that by 4m to the 3rd power, n to the 14 power. So according to this quotient of powers, we're going to take our coefficients and divide them. And then we're going to take our variables and divide them. So to divide exponents, you subtract. So this would be m to the 9 minus 3 power, and the n to the 14 minus 14 power. So 16 divided by 4 is 4. 9 minus 3 is 6. 14 minus 14 is 0. Now, we learned in our box above that anything raised to the 0 power is equal to 1. So this is literally 4m to the 6th power times 1, which would just be 4m to the 6th power. All right, let's look at B. We have 2a to the 12th power divided by 6a to the negative 3 power. So again, I'll take my coefficients and divide them, and then my a's. So to divide like bases, you simply subtract the exponents. So we're subtracting 12 minus negative 3. So 2 6 would reduce to 1/3. And 12 minus negative 3, remember when we subtract a negative, that becomes the opposite plus the opposite. So 12 plus 3 would be 15. So this would be 1/3 a to the 15 power. All right. Now our next problem we have is written in scientific notation. We have 8.8 times 10 to the 9 power divided by 2.2 times 10 to the negative 3 power. So we'll start it the same way. We'll divide our coefficients, 8.8 divided by 2.2. And then our like bases, our bases are 10. So we'll take 9 minus negative 3. Whoops, I made my parenthesis too small. 9 minus negative 3. And 8.8 divided by 2.2 would be 4.3 times 10. 9 minus negative 3 would become 9 plus 3. So 10 to the 12th power. All right. Now, another property you need to be familiar with is called the power of a quotient. So in this example, we have a over b, that's our quotient, and we're raising it to the m power. And the property says that you just take the power and apply it to the a and apply it to the b. So in words, for any real numbers a and b, where b is not equal to 0, so your denominator cannot be 0, the quotient of a and b raised to the m power is a to the m over b to the m power. So for an example of this, let's say we had 2 squared over 3 cubed, and we wanted to raise that to the 4 power. Then that means I'm going to take my numerator, which is 2 squared, and raise it to the 4 power. And I'm going to take my denominator, which is 3 cubed, and raise it to the 4th power. So in our previous lesson, we learned to raise a power to another power. We multiply the exponents. So this would become 2 to the 8 divided by 3 to the 12. All right, now let's apply this property to the following examples. Example 2. In problem A, we have 2a squared b divided by ab, and all of that is raised to the 3 power. So I'm going to raise everything in the numerator to the 3rd power and everything in the denominator to the 3rd power. So this would be 2 to the 3rd power times a squared raised to the 3rd power times b raised to the 3rd power. And on the bottom, we'll take a and raise it to the 3rd power, and b raise it to the 3rd power. Now let's simplify this a little bit. 2 to the 3rd power would be 2 times 2 times 2, which would be 8. A squared raised to the 3rd power would be a to the 6, and then b 3 over a3 b3. Now let's simplify that. This is literally 8 over 1, which would be 8. Whoops, I meant to do that in blue. So if I divide 8 divided by 1, I get 8. And then we have a6 divided by a3. So 6 minus 3 would be 3. And then b3 minus 3 would be b to the 0 power. Now remember, anything to the 0 power is 1, so this is just 8a cubed will be our final answer. All right, problem B. 2p to the 4th power r to the 4th power over 3p to the 3rd power r. All of that is raised to the 4 power. So I'm going to take everything in the numerator and raise it to the 4 power. Then I'll take everything in the denominator and raise it to the 4 power. So let's start with the numerator. We would have 2 to the 4 times p to the 4 raised to the 4 times r to the 4 raised to the 4. All right, in the denominator, we would have 3 to the 4 times p cubed raised to the 4, and then r raised to the 4. Now, let's simplify that. So 2 to the 4 is 2 times 2 times 2 times 2. So that would be 16. For the p, we would multiply the 4 times 4 to get 16, and 4 times 4 would give me r to the 16. In the denominator, we have 3 to the 4 power. So 3 times 3 times 3 times 3. So that's 9 times 9, or 81. So this is 81. And then p to the 3 times 4, which is 12, r to the 4. All right, now let's simplify that. Now, 16 over 81, that will not reduce. So we'll leave it as 16 over 81. And then for the p's, 16 minus 12 would be p to the 4 power. And then 16 minus 4 would be r to the 12 power. So our final answer is 16p 4r 12 over 81. All right, pause the video and try problem C on your own. All right, welcome back. Let's see how you did. So I raised everything in the numerator to the 4th power. So 2 to the 4 times r to the 20, 5 times 4, times w to the 12, 3 times 4, over r to the 16, 4 times 4, w to the 4. So 2 to the 4 power is 16. And then we're going to subtract our powers. 20 minus 16 is r to the 4, and 12 minus 4 is 8, so w to the 8 power. All right, if necessary, pause the video to correct any mistakes you might have made. If you got that problem correct, let's continue on to talk about negative exponents next. All right, now the negative exponent property says that a raised to a negative power is equal to the reciprocal, which would be 1 over a to the positive n. Likewise, if I had 1 over a to the negative n, that would equal the reciprocal, which would be a to the n over 1, which is simply a to the n. So in words, any non-zero number raised to a negative power is equal to the reciprocal of the number raised to the opposite power. So let's say I had 5 to the negative 2 power. I have a base raised to a negative power. So I want to find the reciprocal of the number raised to the opposite power. So that would be 1 over 5 to the positive 2 power. All right, so let's say I had x to the negative 3. I want to find the reciprocal raised to the opposite power. So that would be 1 over x to the positive 3. Now, we can go the opposite way. Let's say we had 1 over 5 to the negative 3. The reciprocal of that would be 5 to the positive 3 over 1, which is just 5 to the 3. Let's say I had 1 over x to the negative 2 power. That would simply be x to the positive 2 over 1, which is x squared. So you're simply taking the reciprocal of the number raised to the opposite power. Now, let's put that into practice. Look at example 3. Rewrite each expression with positive exponents. So in problem A, we have 3 times x to the negative 4. Now, what I want you to notice is that negative power is only applied to the x. So we're basically taking here 3 times the reciprocal, which would be 1 over x to the positive 4 power. Now, I could rewrite that as 3 over x to the 4. So what I want you to notice is that x to the negative 4, we simply moved it to the denominator and made it the opposite power. Let me say that again. The x to the negative 4 power, we moved to the denominator and changed it to a positive 4 power. So in problem B, we have negative 4x squared y to the negative 5. Now the only part of this term that has a negative power is right here. So that's the only part of the expression you need to move to the denominator. So if I rewrote this, I would have negative 4x squared would stay in the numerator, but the y to the positive 5 would go to the denominator. Problem C, 8 over x to the negative 6. Now, if your negative exponent is in the denominator, then you simply move it to the numerator. So this would be 8 times x to the positive 6 power. All right. Now, in example 4, we're going to go the opposite way. It says rewrite each expression using negative exponents. So what we're going to do is we're going to take the denominator and we're going to move it to the numerator and change the sign. So this would be 7x to the negative 4 if I wanted to rewrite that with negative exponents. All right. So in problem B, we have x squared over y. I want to take that y and move it to the numerator. So that would be x squared y to the negative 1 power. All right, pause the video and try problem C on your own. All right, welcome back. For C, I moved the y to the 4 to the numerator and made it negative. So x to the negative 3, y to the negative 4. All right, example 5. Use the property of exponents to simplify each of the following. Do not leave negative exponents in your final answer. So in problem A, we have 24k to the 9 power, m to the 7 power, divided by 4k to the 3 power, m to the 14 power. So I'm going to divide my coefficients and then divide my powers. So this would be 9 minus 3. And on the m, this would be 7 minus 14. So when we simplify that, 24 divided by 4 is 6. For the m, 9 minus 3 is 6. 7 minus 14. Oh, I'm so sorry. That m was a k. I don't know where I got that. Let me change that real quick. That was k. This is k to the 6. And then we have m. 7 minus 14 is negative 7. Now, we're almost to our answer. However, the instructions said do not leave negative exponents in our final answer. So because this part of our term has a negative power, we must move it to the denominator. So this would be 6k to the 6 power over m to the positive 7 power. Remember, when you move it to the denominator, you change the sign. All right, let's look at B. We have 45 m to the negative 6, p to the negative 2, divided by 15 m to the negative 2, p to the 8. So we'll take our coefficients and divide them. 45 divided by 15. And then m to the negative 6 minus negative 2. And p to the negative 2 minus 8. So 45 divided by 15 gives me 3. M to the negative 6 minus negative 2, this would become plus plus, so that would be m negative 4. And negative 2 minus 8 is negative 10. Now this time, this may be the first time this has happened in this lesson, we have two parts of our term that have negative powers. So those will both have to go to the denominator. So this would be 3 over m4 p10. All right, problem C. Now, problem C is not a division problem. It's a multiplication property. problem. So you're going to have to reach back in your brain to a previous lesson when we learned the multiplication properties of exponents. So to multiply these two expressions together, I'll multiply the coefficients, 15 times -2. And then to multiply, we add exponents. So 0 plus 5. And then on our b's, we would have b to the 2 plus -10. So when we're multiplying, we add the powers. When we're dividing, we subtract the powers. So 15 times -2 would be -30. 0 plus 5 would be a to the positive 5. And b, 2 plus -10 would be -8. Now, the only part of this term that has a negative exponent is the b. So we would write this as -30, a to the 5 divided by b to the positive 8. All right, problem D. This is another property we learned in previous lesson. To raise a power product to a power, you simply apply that power to each part of the product. So this would be x squared and y to the -12. And then we would rewrite that as x squared over y to the positive 12. All right. Problem E, we have x to the 6, y to the 3, divided by x squared divided by y. Now, I'm going to rewrite this problem to make it a little bit easier. X squared, y cubed, don't need to do anything to that. But this x squared over y, I'm going to rewrite it by taking the y up to the numerator. So to do that, you would have to change the sign. So instead of y being to the positive 1, it would be to the -1. Now, remember our rule for dividing with powers. You simply subtract the exponents. So this would be x to the 6 minus 2, y to the 3 minus -1. So that would be x to the 4, and 3 minus -1 would also be 4. So our final answer is x4, y4. All right, pause the video and try problem F on your own. All right, welcome back. Let's see how you did. There wasn't anything I could do to simplify the numerator, so I just left it as is. But on the denominator, I applied that 2 power to everything in the parentheses. So 3 to the 2 powers, 3 times 3 are 9, and then x squared, y squared. And then I divided. So 36 divided by 9 gave me 4. x4 divided by x2 gives me x2. And y5 divided by y2 gives me y to the 3 power. So final answer. Pause the video and fix anything that you got wrong in that problem. If you got that problem correct, you are finished with today's lesson, Division Properties of Exponents.